The next topic in physics is about gases, liquids, and solids. And the first unit is going to be around density. So the learning objectives for this unit are fourfold. You're going to recall and use the equation ρ equals m divided by v. Describe an experiment to determine the density of a liquid and of a regularly shaped solid and make the necessary calculations. Describe a determination of a density of an irregularly shaped object and also through the method of displacement, and predict whether an object will float based on density data. So, the first thing we have to do when dealing with measurement is look at system internationally units. Okay, so basically that is the series of units everybody on the planet uses. Okay, so for volume, it's the cubic centimeter. 1 meter by 1 meter by 1 meter cubed would be a cubic centimeter. And that's what's given there. So 1 cubic meter or 1 meter cubed is 1,000 liters. They are interchangeable in that sense. So in terms of SI units, we have the 1,000 liters being 1 centimeter cubed. Your 1 liter drink bottle would be the same as saying 1 cubic decimeter or decimeter cubed. Okay, just as we have meter long rulers, we also have centimeter rulers. We can measure volume in different amounts. So 1 liter equals 1,000 cubic centimeters or 1,000 milliliters. And 1 cubic centimeter is equal to 1 milliliter. So an object which is 1 centimeter by 1 centimeter by 1 centimeter would be a milliliter. For any given volume, for example 1 centimeter cubed, the metal lead is heavier than aluminium. So we call it a higher density. So lead has a higher density than aluminium. So what does this actually mean? Well, density is the mass of an object divided by the volume of an object. So water has a density, at least at room temperature and pressure, of 1 gram per centimeter cubed. So therefore, 1,000 centimeters cubed, or 1 liter of water, is going to have a mass of 1,000 grams, or 1 kilogram. Other objects have different densities. So for example, wood has a density of 0.75 grams per centimeter cubed, whereas lead, which is a lot denser, has a mass of 11.4 centimeters cubed. So a solid object with a density lower than water will float. This is why wood floats and lead sinks. But then again, why should a battleship made of aluminium therefore not sink? Because aluminium has a density of 2.7 grams per centimeter cubed. Something for you to think about. So how do you calculate density? Well, in the density equation, density is shown by the Greek letter rho here. And density, as we now know, is mass divided by volume, or rho equals m divided by capital V. We can also rearrange the equation to give volume, it's equaling the mass divided by rho, and mass equaling the volume of an object times by rho, its density. So another important aspect of this unit is to be able to use the density calculation or formula to do different calculations. So what I'm going to do now is go through 3 different worked examples where we employ the different equations, which you can see on the right of the page. So for example, what is the density of a block of steel if it has a mass of 9,360 grams and a volume of 1,200 centimeters cubed? So look at the equations on the right, pause the video and see if you can get the correct answer. Okay, so welcome back. So the first thing we have to do is really tear apart the question. So we want to find the density. We have a mass and a volume. So the equation we should use is the first one. Rho, or density, equals mass divided by the volume. So rho will equal the mass of the object, 9,360, divided by the volume of the object, 1,200. which will be equal to 7.8 grams per centimeters cubed. Okay, so remember, of course, you also need the units. The next question asks, what is the mass of a block of gold if its density is 19.3 grams per centimeters cubed and it has a volume of 540 centimeters cubed? So again, pause the video, choose the correct formula, plug in the numbers and see if you get the same answer when we come back. Right, so the one you should have chosen is the second one here. Mass equals the volume of the object times its density. So we have a mass, we have a density, and a volume. So if you plug in the numbers, you should get the answer of 10,422 grams. Finally, what is the volume of a block of ice if it has a density of 0.2 grams per centimeters cubed and a mass of 12,462 grams? So again, finally, pausing the video and choosing the correct equation to use, plugging in the numbers to get the correct answer. Okay, so you should have chosen this formula. The volume equals the mass divided by rho, the density. So you should get a volume of 12,462 divided by 0.2, or 13,546 centimeters cubed. So the next step is to work out the volume and density of objects. So the volume of irregular objects is kind of easy to work out. You use mathematics. Okay, so for cubes and rectangle blocks, just use length by height by width. Okay. For cylinders, it's simply the pi times radius square times the height. Not a problem. The problems come when you're working out volume and density of a non-regular shape. Okay, so for volume of a liquid, you simply use a measuring cylinder. Okay, you essentially read off the level of the scale to get the volume of the liquid. Now you have to be careful, of course, because you have to deal with something called the meniscus. Okay, so if you look down, you will see on a measuring cylinder that it's not quite straight, the surface of the liquid. There is something called the meniscus. Okay, it's called a meniscus. Okay, so to measure the volume of a liquid, what you have to do is you have to basically read from the bottom of the meniscus. Okay, so you get a value on the marking of the measuring cylinder, and you read from the bottom of the meniscus. In terms of working out the volume of an irregular solid, there are two possible methods. Okay, the first thing you could do is using a measuring cylinder. So what you do is you have your volume before you've added the irregular object, so you read that off, and then you add the irregular solid and measure the volume again. So you've got volume number 1 where the object's not been added yet, and volume number 2 where the object has now been added. And the volume of the irregular solid will equal the volume after minus the volume before. So for this particular example, it will be 235 centimeters cubed minus 155 centimeters cubed, so it'll be 80 centimeters cubed. The other way you can do it is using something called a Eureka displacement can, which is this thing right here. Okay, so what you do is you fill the Eureka can until it stops overflowing. Okay, so about to this mark here, just before the spout. Okay, and then you gently lower the irregular solid into the can and measure how much water is displaced. So what's going to happen as the object enters, the water is going to displace into the measuring cylinder, which you can then record the volume as usual. So therefore the mass, if you know the mass of the irregular solid, for this example will be 350 grams, and the volume that the irregular solid has displaced, which is 80 centimeters cubed, you can work out the density. It will be mass divided by volume. So in this particular case, it will be 350 divided by 80, which is 4.3 0.75 grams per centimeters cubed. And that, in a nutshell, is what you have to know for the topic of density.
Some of the best opportunities to learn are the moments in which we are perplexed, those moments in which you begin to wonder and question. These moments have happened throughout history and have led to some truly amazing discoveries. Take this story, for example. There once was a fellow named Archimedes. He was born in 287 BC in the city of Syracuse in Sicily. He was a Greek mathematician, physicist, engineer, inventor, and astronomer. One day, Archimedes was summoned by the king of Sicily to investigate if he had been cheated by a goldsmith. The king said he had given a goldsmith the exact amount of gold needed to make a crown. However, when the crown was ready, the king suspected that the goldsmith cheated and slipped some silver into the crown, keeping some of the gold for himself. The king asked Archimedes to solve the problem, but there was a catch. He couldn't do any damage to the crown. One day, while taking his bath, Archimedes noticed that the water level in the bathtub rose and overflowed as he immersed himself into the tub. He suddenly realized that how much water was displaced depended on how much of his body was immersed. This discovery excited him so much that he jumped out of the tub and ran through the streets naked, shouting, "Eureka!" which comes from the ancient Greek meaning, "I've found it!" What did he find? Well, he found a way to solve the king's problem. You see, Archimedes needed to check the crown's density to see if it was the same as the density of pure gold. Density is a measure of an object's mass divided by its volume. Pure gold is very dense, while silver is less dense. So if there was silver in the crown, it would be less dense than if it were made of pure gold. But no matter what it was made of, the crown would be the same shape, which means the same volume. So if Archimedes could measure the mass of the crown first, and then measure its volume, he could find out how dense it was. But it is not easy to measure a crown's volume. It has an irregular shape that's different from a simple box or ball. You can't measure its sides and multiply like you might for other shapes. The solution, Archimedes realized, was to give the crown a bath. By placing it in water and seeing how much water was displaced, he could measure the volume. Then he'd calculate the density of the crown. If the crown was less dense than pure gold, then the goldsmith most definitely cheated the king. When Archimedes went back to the king and did his test, the story says, he found that the goldsmith had indeed cheated the king and slipped some silver in. These days, using the way an object displaces water to measure volume is called Archimedes' principle. The next time you take a bath, you can see Archimedes' principle in action. And maybe you'll have a genius idea of your own.